And now I would like to formally introduce Dr. Caitlin Wood. Dr. Wood is an assistant professor in the Department of Anatomy and Cell Biology at the University of Western Toronto. Oh, sorry, not Toronto, Ontario. Sorry,
Same
my bad.
province, it's okay.
Yeah, still have Toronto on the brain.
Yeah.
Her anatomy teaching ranges from large undergraduate courses, which are delivered online and asynchronously, to smaller groups of graduate learners in the cadaver lab from the medicine and dentistry programs. And we are so excited that she is here with us today. So, Dr. Wood, floor is yours.
Thank you, Courtney.
You
And
are
thanks so much
most
for
welcome.
having me. I think that this is a really great opportunity just to connect with sort of like-minded people who are interested in similar things. So yeah, Courtney basically did my job and gave you guys a background of what I've been doing, but let's see. So we'll go a little bit more. So, as Courtney sort of mentioned, the pilot project that I'm going to talk to you about today was from my teaching within the Faculty of Health Sciences at Western University. So, this is a mandatory core course for all students within the Faculty of Health Sciences. So, these are first year students in the nursing department, kinesiology, and health studies. So, coming from a variety of different backgrounds. And the enrollment is about 1,500 students annually. So, in the cohort that we employed this pilot, we had about 900 students. So you can imagine 900 undergrads is a lot to manage. And before the pandemic, everything was taught online, or sorry, in person. Lectures and labs were all in person. And then, just like everybody else, during the pandemic, everything was rapidly shifted online. So lectures and labs all went online. And now in 2024, we're offering the course in a hybrid format. Since the pandemic, we've increased our enrollment, and as such, we don't have a physical space to hold all of these students together at the same time anymore for one in-person lecture. So lectures are offered online and asynchronously, and then labs are still offered in person. So these are a group of students who will come together for a 1 hour in-person lab session. And that's really the only in-person time that they have with us. So as such, one of my main questions was, how do we make this in-person time in the lab really meaningful for them? If this is the only time that they're going to ever see us as instructors in a face-to-face way, how do we engage them with the content in that 1 hour section? And specifically because our program only uses plastic models. So the gold standard for teaching anatomy is largely considered to be cadaveric dissection. And that's not something that's a reality for our program. Okay, so plastic models, they do have some pros. They're cost effective. They are easily accessible to most programs. They can be constructed and deconstructed by the students, as you can see in this middle picture. And they have been shown to improve spatial and long-term retention. Of course, they also come with some cons. They can be considered to be unrealistic. They are plastic. They can degrade over time. You can start to lose pieces. And they do require a certain amount of intrinsic motivation from the students to actually build them or put them together. Okay, so we had a few things that we were struggling with. If we go back a little bit then and talk about anatomy education in its entirety, by nature, it can be difficult for students to learn and understand. It's a lot of terminology and it's a lot of content. So there seems to be a need to have some type of innovative teaching methods for students or for instructors to employ to improve students' capacity for learning. Teaching aids are generally considered to be critical tools in anatomy. Okay, this is so that they have something to visualize those anatomical structures. Like I said, cadavers are generally considered to be the gold standard, as are prosections. And then plastic models are also used as well to varying degrees of success, let's say. There has been lots of research done in terms of anatomy education. Okay, we know that digital tools is one of the things that people are starting to talk about, specifically including things like augmented reality and 3D model viewers. And whether those tools can help to facilitate learning in this context. Results so far have been ambiguous. Some researchers will say that they do not offer any significant learning benefits, whereas others will actually show them to have a higher acquisition of knowledge in students and a greater interest for learning. So really this led to us asking the question, can 3D models and augmented reality offer an innovative solution to enhance anatomy education? And further, can the integration of AR and digital 3D models enhance the overall learning experience as measured by engagement, motivation, and learning over traditional methods, which in our case was these plastic models? Okay, so that's where we were sort of coming to or coming from with our pilot project. So we used undergraduate students, okay, from the Faculty of Health Sciences. As I mentioned, this is a cross-listed course, so we had students from a variety of different disciplines or backgrounds. And we used Visible Body. So we brought in Visible Body as a learning tool, a digital tool for our students within their lab-based session. So because we had so many students, we have a lot of lab sections. Okay, so there's actually 30 lab sections. And this is across all of our disciplines. So 30 lab sections, say there's maybe 10 for each kinesiology, health studies, and nursing. And we divided them into 6 study groups. So some of the groups were only given the plastic models or what they are used to seeing in their traditional labs. Some were given what I'm calling VB. So this is Visible Body, but the desktop version. So this would be on their own personal laptop or on a tablet, which we supplied for them. It could also be on their mobile device. Some groups were given AR, so an augmented reality group. Okay, they were told to only use the augmented reality tool. They were not given plastic models, and they were not asked, or they were asked not to use the desktop version. And then we had a few combination groups. So of course we had students who were using the augmented reality option plus plastic models, Visible Body, the desktop version with the plastic models, and then of course the combination of Visible Body desktop plus augmented reality. So those were our 6 individual study groups. This was carried out over 1 week. We really wanted to make it more than 1 week, but time just was not on our side. The fall term is very busy. This is a big course with a lot of moving parts. So we ended up using 1 week worth of content where we looked at the lower trunk, essentially. So we looked at some abdominal muscles, some glute muscles, and some upper thigh and hip muscles. All of the groups looked at the exact same content. One thing that we found very quickly into our 1 week study session is that it was really hard to limit the students to only using augmented reality. So I'm sure you've all seen Visible Body before. If you haven't, this is sort of what it looks like. This is just me popping up augmented reality skeleton in my living room. So we basically handed them the tablet in this format. So the blue button was clicked on. They were in augmented reality mode, and we asked them to explore some musculature from the lower extremities. They were given a worksheet. They had sort of a dedicated task. But what we found was that they just started to click off this blue button and go back to sort of this desktop version. The AR component has some features that we thought were super cool that they would like, meaning, you're using your fingers to sort of rotate, or you're using your device to rotate around the body. You're sort of zooming in by going in and moving back, a little bit more interactive, a little bit more, let's say, physical, if you will. But we found that they just kept clicking off the AR, and it was really hard to limit them to this. So in order to keep things consistent, we had to take out our AR group. So that left us with 3 study groups. So we had one group that was only using plastic models, one group that was using the desktop version of Visible Body, and then one group that was using both together. So the both together group was actually really awesome. We had some assistance from the team at Visible Body, and they actually came up with QR codes for us that we could put onto the muscles on our plastic models that they could scan with their phone in the Visible Body app, and it would take them directly to an image within Visible Body. So that combination group really was a combination or an interdisciplinary sort of group. So that was really awesome. So as I mentioned, they all had a worksheet to work through. Okay, I gave them some tips and tricks on how to use Visible Body. As I mentioned, we gave them an iPad. So we had teams of 2. So students worked in partners where they had a tablet and Visible Body was available to them. And then they had a paper workshop that they sort of worked through to give them, I wanted, like you can see here, I'm asking for what is this muscle? What is its action? Things that they could find both on the plastic models and on the digital tool, which was Visible Body as well. Because this was a research project, students completed a content quiz before and after, and then they completed a survey upon completion. Okay, so we asked them about the experience that they had in the lab. For some of the students, especially the ones who had the plastic models, obviously, this lab would have looked no different from what they would have traditionally seen in previous labs throughout the course. In terms of some results, then, we have both quantitative and qualitative results. So I'm showing you here some results for attention. You can see in this top panel here. Let's see if I can get a laser pointer. Hang on, sorry. So you can see attention here on this top panel, relevance, confidence, satisfaction. On the x-axis at the bottom are our three groups. So you can see plastic models, the group that had Visible Body Desktop, and then Visible Body Plastic, or our combination group. Okay. Mean Likert scale 4.5, meaning, that they strongly agree, or it was strongly motivating for them. It was a higher value versus 0, which is basically disagree or did not like. Okay. The different symbols indicate the different questions. It doesn't like it when I go from laser pointer to no laser pointer. Apologies. Okay, so this is sort of strongly agree to agree. There we go. And then the green points, which I didn't feel like you could see very well here, so I ended up highlighting them in a green circle for you. But these are the ones that show a significant difference from the plastic model treatment. Excuse me. So this is anything that's different from plastic by itself. Okay, these are standard error bars here. So you can see some differences right away. Cognitive load, for example, is lower, they're saying, with the use of Visible Body, for example. Engagement and interest higher in the combination group as compared to the plastic models. Relevance, so this is relevance to the content. They found that Visible Body enabled them to have a more relevant experience in what they were learning. Satisfaction, which I personally think is fantastic using Visible Body. They really engaged in this lab, which was amazing. And then this one up here, the attention one, I'm going to highlight this on the next scale because this one is separated into faculty, if you can see. So we have health sciences, kinesiology, and nursing. Excuse me, sorry. So these are just a little bit bigger for you here. And specifically, I want you to look at this group here, health sciences. So look at the difference in attention in the group that had the combination. Even Visible Body here, the different lines show the different questions that were related to attention or satisfaction. So you can see that our combination group, especially in our health sciences students, was really, really positive. Okay, and this is the numbers for you over here. So while we had more kinesiology students, the health sciences students are where we saw the greatest benefit, let's say, of incorporating this digital tool. And for me personally, this was extremely motivating because this was one of the main groups that I was really struggling to connect to. And what we were finding was that before we brought this in, our kinesiology students were engaged in the content. They knew that they wanted to be there, right? They had a purpose for being in anatomy that was going to sort of fulfill their future career, right? So whether they wanted to do physiotherapy, whether they wanted to do medicine, they knew that anatomy was important for their future goals. Same with nursing for that matter. But health sciences is so vast and so broad. We had students there who maybe just wanted to be an admin secretary, or they wanted nothing to do with actual anatomical structures. And so this course being mandatory, it was really hard to reach them. It was really hard to engage them or motivate them to want to learn. So to see this for me was like, yes, this is what I wanted. This is why we're doing this. We're trying to reach those students who didn't really want to be reached realistically, right? They could not engage, or they were having a hard time. Those plastic models, for whatever reason, just presented too much of a barrier for them to even engage in the content. So this was a big one for me. We do have also some qualitative data. which I will show you. So as I said, they completed this feedback survey at the end, which basically asked them, how did you find this experience in the lab today? So everybody got this. So these are some comments, example comments from people or students in the plastic models only group. I've given you a count of comments here, but we had over 400 students give us verbal, or I should say written, feedback about their experience in this lab. So from those 400, I was able to do a thematic analysis or a content analysis and got them down to 5 different themes. So we have learning preferences, we have things that enhanced their learning, we have students who had obviously some criticisms of the modality in all different modalities. And then we have areas of physical anatomy where learning was specifically improved. So this is where students are actually commenting on, for example, a region of the body or a topic within. So this student, the lab today allowed me to understand the hip, gluteal region, thigh, and knee. Great. They also have some criticisms. I enjoy learning with the plastic models because they allow me to visualize the lessons that I have learned, but they sometimes look different than the ones in lecture, which can cause slight confusion and make association difficult. Absolutely, right? So you can just see here sort of like an indication of, students still had, there's 70 comments that came back with, a positive opinion, let's say, for plastic models. So they're not the worst thing in the world. However, some of our comments from groups with visible bodies. So this is the desktop app. Expressing a preference for learning. You can see our count is a little bit higher here. Today's lab was interesting because we got to view different models on the same screen and also got information about them. Whereas the plastic models you can get a better view of, but you don't get any information from it. I found this was a really common theme where something that students struggle with, and especially when it comes to cognitive load with the plastic models, is that they have them, but it's up to them to reconcile what each of the muscles are, right? And so there's no labels on them. There's no labels to the innervation. There's no labels to what the muscle names are. And that's something that they really appreciated with visible body is, well, they can try and make an educated guess. They can also just click on the muscle and see the muscle type, the muscle function, the innervation, all of the things that they would want to see. Sometimes there's even videos of that muscle in action. Say it's an adductor, right? And so it'll actually show you that muscle in a deduction, which is amazing. And that's not something that you can get from the plastic models. Something in a way that it enhanced their learning, helps to see the entire body and how structures interact with one another. Being able to view separate layers is beneficial because you can see the position of structures relative to one another. It helped me better visualize the muscles of the body. I found this one came up again and again where students really appreciated being able to see the different layers of the muscles. You can sort of toggle on and off, fade and hide and things like that, which, yes, you can technically do by taking the muscles apart for plastic models, but this allowed them to actually see it and how it relates to all of the other ones in a different way, right? In that 3D sort of aspect. Of course, there's going to be criticisms here as well. Going back and forth between models was inconvenient. It froze occasionally. I preferred the hands-on models because it's nice to be able to physically hold something and see all sides of it in 3D. Absolutely fair. Okay, so that takes us really nicely into our combination group where students had the access to the digital tool, so visible body, as well as our plastic models. So for these ones, holding a physical model is nice for seeing all angles of the body part. However, using the digital tool is helpful for understanding where this body part is oriented in reference to the whole body. Much easier to navigate and has descriptions, which made it easier than asking for a TA's help if they were busy. I think that's a really crucial comment as well, because it shows a preference for sort of self-directed learning, right? So often in these small group labs, we can get reliant on the teaching team to be like, is this right? Did I do this right? Is this the right muscle? And that's great. And there's a place for that as well. But in order, enabling the students to have, or empowering, I should say, the students to have their own capacity for learning and just being able to say like, hey, I know how to find this answer, I think is really powerful. And that's a really great component of this program. Some of the limitations, they said the pros of using both was that I got to apply visual and kinesthetic learning. The cons was that the software took some time to get used to and orient myself with. Because this was a research study and because we were using it as a pilot project, we really did not give them much time for familiarization. And moving forward, that's something that we fully incorporated into the course. So the comment about, there was a learning curve was common among the feedback. And that was totally fair. That was on us. But we were also trying to be cognizant of the fact that we had so many different lab sections, and we were kind of being a little bit, we're researchers, so we were trying to keep the groups separate, right? Well, there is going to be some communication outside of the lab. We were trying to keep it limited. And we tried to say, to the students to say that these people maybe are going to get visible body, you're going to get plastic models. They didn't really know that when we first started this. So we were trying to keep it as separate as possible, which is why we eliminated, giving out the links ahead of time, or, giving them a full learning sort of video like we have now from visible body, because we wanted to keep the groups separate. We didn't want the plastic models group to know necessarily what they were missing, if that makes any sense. And so I think I'm going to come back to this slide here, which is our comparison, right? So students were asked, compared to previous labs where you have only used plastic models, in the groups that had plastic models, they were asked to just compare to previous labs. Did this lab, or the use of visible body, better facilitate your learning about anatomy? And so you can see this green little mark here, which really shows that it's this combination of both the hands-on and the digital tools that the students really appreciated and ultimately facilitated their learning about the content, which was our objective to begin with. So I think some of our takeaways then are that plastic models are still relevant and useful. They do offer a hands-on experience that students seem to need, especially for a course that is taught entirely online. I think that's something that we really need to consider. However, digital tools are also useful, and they can help to fill the gaps in learning that are created from these plastic models. So some areas where the plastic models maybe can't make up for example, the layers of the muscles, labeling, actually being able to see the movements. One thing that we noticed is that our plastic models are really lacking for the deep back muscles, and that was part of this lab. So those students who had the digital tool for that one exercise actually had an advantage over those students who only had the plastic models. Ultimately, the combination of the digital tools and the plastic models can have additive effects on learning and improve accessibility for all learners. I think that comes back to the point about it being potentially more self-directed, but also the option for collaboration. If you want to work in partners or groups or pairs, that can happen as well. You're also totally able to just work solo. You're able to work at your own pace. I think that those things are all really important pieces here. We do have some next steps. So we are looking at a different background of students this summer and into the fall. So we're looking at students who actually come from an anatomy background, who are part of an anatomy course. And we're looking at it specifically in a remote or online group. So where they do not have an in-person option, they are entirely learning online or from 2D images, essentially. And then we have some more data collection planned for the fall as well. Some other questions that we'd like to ask, which is, is there discipline-specific motivation to learn? So looking a little bit deeper into that kinesiology, health sciences, nursing, maybe anatomy sort of differences. Does size matter in terms of group size? So as I just sort of alluded to, partner sizes of groups versus groups of 4 or 5, even things like screen size. Did it have an impact on their experience with, a mobile version versus their desktop or their laptop? Is there a correlation between augmented reality learning outcomes and visual spatial abilities? We're going to assess this by the MRT survey. Mental rotations test is what that means. We are going back to using the augmented reality. We're going to find a way to incorporate a little bit better than maybe what we did. And then specifically, are there other topics that benefit more from 3D tools than others? And that was sort of what I was alluding to with, for example, the deep back muscles. Maybe digital tools are really fantastic thing for the musculoskeletal system. So looking at bones and muscles. But then when it comes to learning about, the digestive system, for example, they're not any better. Maybe just plastic tools are as great to view, the stomach and the kidneys and things like that. So there's a lot of different questions that we'd like to ask here. I think there's a lot of different ways that we're looking to incorporate visible body moving forward. And yeah, all of these questions excite me. I think that these are all completely valid and all really relevant for the students that we're seeing today. And yeah, I think we have some really great questions and answers to be found, let's say. So with that, I will say thank you very much. Also a mention to my co-investigators, Dr. Paul Mensing and Dr. Sean McWatt. We were all sort of in this together, and we will continue to be. So that's that. I'm happy to take questions if there are any.
Excuse me. Yes, we do. We have our first question from Lynn. Thank you, Lynn. Lynn says, I believe you talked about visible body assisting with the combination plastic model and visible body group set up by linking them. What does that linking look like?
Oh, so I think I believe you talked about assisting with the combination. Yes. Okay. So Kara can help me with this because Kara and Brandy from the Visible Body team are who helped me with this. It was totally their idea and it was amazing. So we told them what content we were looking to cover in our lab. So we said, we're going to be looking at the thigh, the hip, the gluteal region, specifically these kinds of muscles. And then Brandy was like, okay, here's a couple of QR codes that link specifically to different pages within the app. So the students we took those QR codes and put them on the muscle, specifically on our plastic models. And then the students with their tablets were able to just scan that QR code, and then it popped up on Visible Body from that page that Brandy had picked, which was specific to that region. So it was entirely seamless, and it was all done by Visible Body. We just sort of gave them a little bit of helpful advice or helpful information to start it off, and then they kind of ran with it, and it worked out amazing. Oh, Courtney.
Sorry, I'm muted. If anybody has any questions that they would like me to unmute them, so you can actually ask them. You can use the hand raise feature in Zoom, or if you're a little camera shy, feel free to pop any further questions in the chat. Is there a way to print QR codes ourselves? This came from Frank.
Carol,
yeah, so you can print the QR code. It actually comes up. So when you go to the model, it'll actually say you can like share a link. And when you hit the share link, that's where it gives you the QR code. So you can print that yourself easily. Now there's these new tools. They're very small little printers. They're like the size of a cell phone, basically. And you can actually print from those as well, which is really cool because it'll print out a sticker for you, and then you can just stick it on your model or stick it on the wall next to, whatever you have.
Oh, Courtney, you keep going on mute.
Yeah.
Sorry. I was going to say, I am trying to pull up Visible Body Suite right now so we can show the QR code functionality.
Do you want me to answer one of these other questions? Can I do that? Okay, so one of them says, what type of questions did the students answer that were on the worksheets? So really great question. The worksheets themselves were just a way for us to get them to actually use the tool because in any lab, we can sometimes have students that just sit there for an hour and socialize. And there's a place for that. I appreciate that. But we really just wanted to get them using the tool, whether it was the plastic models or Visible Body. So the worksheets themselves were not overly complicated. We just wanted them to be like, click on a muscle and tell me the innervation of it. So meaning I wanted them to be able to see, what kinds of information they can get from clicking on a muscle, or I wanted them to use the tools to rotate the skeleton or zoom in on a muscle or things like that. So the worksheets were not complicated. They were content-based. Meaning, there was a couple of questions about like, what's the function of this muscle, or what's the innervation of, this or that kind of a thing. But they were not complicated, and they were purely just for engagement and interaction within the lab itself. Hopefully that answers your questions.
Kara, Alicia had a question about, I don't know if this was a question for Dr. Wood, or about visible body actually in Alicia's classrooms, or classes rather.
Yeah, we can connect you to your rep, Alicia, and then they could get you trial access if you're looking to try it out. If you could just let me know where you're located so I can direct you to the right rep.
In the meantime, I am actually going to share my screen so I can show off the QR code feature in Visible Body Suite.
Yeah, perfect.
Okay. Can everybody see my screen?
Yep.
Okay, perfect. So I am in Visible Body Suite. This is our flagship product. So as you can see right here, I have a skeletal muscle microanatomy model. So you can see the different levels from macro to microanatomy. And say that I wanted to create a QR code that I could print out and put on, say, a plastic model of something very similar. We have the share feature down at the bottom right of our menu here. So if you click share, you would click share link, and the app will generate a QR code for you that would take you to this exact model. So you can either download the QR code or take a screenshot of this and print it out just as easily from your computer, and just cut it out and tape it onto your plastic model.
Perfect. Thank you. I didn't even know you could just do that myself. It was a really amazing tool, and the students actually really commented on how much that helped them be able to use the combination tools for sure.
Does anybody have any questions for Dr. Wood about her study or about the product that we can answer for you?
I didn't put my email address on the last slide, but I'm happy to put it in the chat if anybody has specific questions. I'm more than happy to answer questions by email at a later date as well.
Yes.
Thanks, everyone. No problem.
Oh, perfect.
My pleasure.
All right. Well, barring any further questions, I suppose we can end things a little bit early. I want to thank Dr. Wood once again for sharing with us her study, and thank you all for joining us today. Be on the lookout tomorrow for the follow-up email, which will have the recording to this webinar, as well as some follow-up goodies. I'll include some more information about the QR code functionality, and some ideas for potential labs that you can do with your students using Visible Body. And yeah, thank you so much for spending this time with us, Dr. Wood. Once again, thank you so much.
My pleasure.
And
thanks for having me. It was great. I appreciate it.
Anytime. You can come back anytime.
Yep.
I will. Think you're ready now.
Can't threaten me with a good time.
Yeah.
All right, everybody. Thank you so much. And we will see you next time.